Hello everyone, welcome to another video. In this video, we're going to be introducing the idea of using collection like data types such as strings, lists, sets, dictionaries, and so on. But in this one, we're mainly going to be focusing on list and a little bit of strings. And then we're going to be learning a new algorithm as well called selection sort. So the overall problem of this video will be that we're going to be trying to sort names, and these names are stored in a text file called names.txt, and we're going to sort these names stored in those text files in alphabetical order from A to Z. Once we have fully sorted it, we will then get those names and store those names in a new text file called sortednames.txt, and that will be the goal of this video. So let's get started. So right now what we have is this name order.py, and our problem is we want to sort the names. I have a names.txt file which has this many last names. I asked ChatGPT to generate random last names, and this is what it generated. And then with our program that we're going to write, with our Python program, we're going to access that text file, grab all the names from it, sort it by using a selection sort algorithm, and then we will write the names into a new file called sorted names. So let's get started. So I decomposed this problem into 3 sections. We need to read the names from .txt and store them in a variable. Then number 2, we need to sort the names in alphabetical order. We will use this algorithm called selection sort, and we'll follow this algorithm. And then we're going to write the names into a new file called sortednames.txt. So let's do this. What we want is the names to be stored in a variable. So I'm going to call these names. And what I'm going to do is declare an empty list that can store our name string values. So in our names.txt, we have separate names. And what we want to do is, since we have multiple values, and normally variables can't hold multiple values unless it is a data type that holds multiple values. And we're going to be utilizing a data type called list. List is a data type that allows us to hold any type of data types within it, but multiple variations of them, so we can have all the names be stored as separate items within this data type called list, and our variable is called names. Whenever we do file input output read write, what we want to do is always write a with statement, and here we want to access name.txt, so we're going to open that file, so we must reference that file .txt. Right here, I'm saying the period here means in relation to where my Python file is located, within that same directory, I'm looking for names.txt. And then I'm going to do comma that with the quotation mark R, saying I'm not going to be modifying that file, but rather I'm just going to read the data content that is stored in names.txt. And then this entire result of the open function that's occurring right now, we're going to be labeling that as our data file. Okay. So we start off with that, and it starts a code block. The code block is going to start as follows. We're going to say that for each individual name that we have, or let's call it a line. Let's say a line of data that we have inside our data file when we read lines, which every file object, because this open function returns a file object, every file object has the ability for us to read the entire contents of it as read lines, and then I can say print line. But what I want to do instead is comment this out and show you what this looks like. We can do a print data file of the read lines, and then if we execute this code, we will get a list containing all the names, but unfortunately we have the /n there, and that's not something that we really wanted. So what we want to do is, well, now let's use a for loop, read through all the values that we are reading, which one by one, and then remove the /n, and that's what we're going to do. So now what we're going to say is, instead of printing all that, we printed list to see what it generates. And then what we're going to do is we're going to traverse through the data underscore file read lines, which is going to be looking at each individual names that we have here. And then what we're going to do is add them to our list called names. So we're going to ask names to append a value. And the value that we want to add is going to be line, which is the individual item that we have here. It's targeting Williams at the moment, but I want to get rid of the backward slash n. And with the string, if you ever want to remove something, we can write the word replace, write the pattern that you want to replace it with an empty string. And it will look for all the occurrences of this and change it with an empty string. And since our value's been cleaned up, we're going to be adding that value into names.append. And now, end of getting names, we can do a print of names, and we clear, run this code. Now I have a list with all of our last names stored in this variable called names. So far, what we learned is the following. Each individual line in our loop was a string. Every string has only strings. Strings has a method called replace, which looks for the first pattern and replaces it with the second pattern. For strings, for all strings, we can use the .replace method to replace an old pattern with a new pattern. And that is something I do want you to read about in the future so that you can use that replace with strings and later of your code. When you have a list, if you want to add a value to the end, we call that append. Every list, or we'll say for all lists, we can use .append to add the given argument to the back of the list, so forth. And now we have our names. Awesome. What we want to do next in our program is our second functional decomposition, sort the names in alphabetical order, and we will use the selection sort algorithm. And the selection sort algorithm goes as follows. We're going to assume that the very first item that we have is our initial position, and we're going to assume that that value is sorted. Then we immediately look at the value next to it until the end of the list, and then we are going to grab the smallest value. Okay, if that value is smaller than the one that we initially started off with, we're going to swap their location. And now we are at an agreement that the very first element in our array is now sorted. Now we can look at the second one to see if there are any values that is smaller than it, so that we can find a new minimum and swap those two as well, and so forth. And that's what we're going to be coding with, interacting with names. So what I wanted to do first of all is, well, let's try to do a single run through, single pass of, oh, how can we assume that this first one is our initial starting position, and how do we look for the next smallest? Okay. So what we're going to do is say we're going to have a testing array of 3, 1, 4. And then I'm going to turn this off because we don't need to see it anymore. We're going to say we're going to have a testing array of 3, 1, 4. All right. And then our current value, all right, well, let's call this initial position. Well, would be test at 0, which would be our very first position. And then we need to do a search for the smallest value. So smallest value afterwards would need to be found at index 1 and onwards. So we can say while I is less than the length of test, and then it needs to be 1 greater than this, so we're going to do I is 1. And then while I is, we're going to say that I is less than that. Smallest value is going to be smallest value. We're going to initialize that as test at I. And then while I is less than length of the test, we're going to say smallest value is equal to, we're going to compare the minimum of smallest value, what the value of it currently, compared to test at this index of I. And if they're equal, it doesn't really matter. And then each after each loop, we're going to do I plus equal 1. And then we're going to say that if smallest value is less than initial position, that just means that initial position should have the value of the smallest value. So we're going to say temp is equal to smallest. We're going to say it's the initial position, because we need to swap those values. And then we're going to say the smallest value is the we're going to say the initial position is now going to be updated with the smallest value, and then smallest value would be updated with the value of temp. And this is the logic that we want to write, and we're going to be writing a lot of tweaks on this and so forth. So to start off, we have a list of names, and I want to systematically access individual items in that list with index I. So what we want to do then is the following. We always want to set, we're going to have our index variable set to 0. We're going to say while I is less than the length of names, our names list. And then we're going to say that print names at I is names at I, like so. Let's see what happens. We forgot to, we're stuck in an infinite loop. We forgot to increase our I to go up by 1 to make sure that we make this while loop's condition false so that we can actually get out of that while loop. Let's run this again. And on 50, we have Porter, and on index 0, we have Williams. So we're able to now systematically access our names that we have in with a while loop or with an iteration. Then what we want to do is, well, we're going to assume that our very first value of Williams is sorted. Now we need to find the smallest character, or the smallest or the most minimum or the most front side of our alphabetical ordering last names from 0 plus 1 onwards. So what we're going to do is now here we want to write while j is less than the length of names. Right? And then we want to do j is equal to I plus 1. Just we're making sure that when we use this variable j is always going to be greater than I by a value of 1. Right? And then we will say the smallest is equal to names at I, where this is our original smallest value that we are starting with. Then we can say the following. We can say that we also have to say smallest name. Then what we also need is the smallest index, because you need to figure out where that started, which is going to be right now j as well. Now we're going to say that while j is less than length of the names, we're going to do if names at j is less than the smallest name, then smallest name becomes names at j, and then the smallest index is going to be updated with the current j as well. And if that wasn't true, we don't have to do any updates, but overall we're going to need to increase j by 1 so that we can continuously loop the inner loop. So we're going to say end of inner while. Okay. So on smallest name, awesome. Then we can say the following. We can say if names at I is, or if names at smallest index is less than names at I when we're here, after this entire loop is over, we can do the following. we can say that names I and names at smallest index, or we can use this variable here. Smallest name less than names at I. We're going to say that names at I and names at smallest index is going to be swapped. This is how you do a index swaps in Python. Names is going to have smallest index, and then names I. So whatever the value at smallest index was is now going to have the value at names I, and names I is going to have whatever the value it was in name underscore index, and we have swapped that. Therefore, we are now guaranteed that I at 0, when we first start this, it is sorted. So at this point, what I want to do is I have I plus equal 1. I'm going to print names, and then we're going to write a little break here to just show you what has happened. Then we'll also put a print names here to see our before and after. We'll clear, write our code, and as you see, we have Williams being our very first sorted and considered to be the current minimum or the current almost on the front side of the alphabetical order, but it isn't. It starts with a W. And what we did was from Thompson all the way to Porter, we found the name that would be considered the smallest of the alphabetical number and names, and it ended up being Bailey. So we were able to switch Bailey and Williams's location at that moment, and they were able to swap. And now we know that Bailey is the smallest one. And then I would increase to Thompson and target Thompson, and it'll try to find the next smallest value that is greater than Bailey but smaller than Thompson, and it will swap those two locations. So let's see what happens afterwards. And we can say that end of while. And then we can do a print names just to see what it outputs by the end. And then here we go. We have Bailey, Barnes, Bennett, all the B's, all the C's together, and so on. And it ends up sorting our given names from ChatGPT that exist in names.txt, and that they were all located right there. So we can now get rid of all of our print statements that were used for testing, and so on. Then we can say that this is an F string of sorted names, like so, and then we'll put a /new line there. So we have our names all sorted, and we have our sorted names. Perfect. So we did part 1. We were able to read the data from a text file. We did a part 2, which was the implementation of our selection sort algorithm written in Python. And then what we're going to do is the following. We're going to write the names into a new file called sorted names, and this is very similar to step number 1. We're going to use our with statement again. So we're going to say with open. This time we're going to create this file called sorted names.txt, and then we're going to do a W because we want to write onto that new file as a data file. And then the data that we want to write, so we're going to say the data that we want to write is called data. And then we need to loop through this sorted names. So we're going to say for line in names. We're going to say data is equal to a formatted string of line. And then we're going to add a \n. And then we're going to ask data file to write the data that we generated. And after that is done, we will write print sorted names completed. And then that could be the end of our code. So let's run our code. And if you see here, we have all the last names sorted in alphabetical order, starting from 0 to 50. There we go. Okay. So today we learned how to read text data from a text file by using the with open structure, and we have to use r as the second argument in our open, and then we have to create this variable called data underscore file, and we learned that there is a method that allows us to grab values. We also learned that today that with strings we can do a replace where we can look for a pattern that we want to replace it with some other pattern, but in this case we wanted to remove that, so I just replaced it with an empty string. Therefore it won't take up space with the /ends being written there. Right? And we learned that with lists, if we want to add a value to the end, we use the append method to add whatever value we have within the argument to the list that you're targeting. Then we learned what a selection sort was. We start with the first element as the initial position. Then we find the smallest element in the unsorted portion of the array, which is right after the first element that you targeted. Then we swap them if the smallest number found was smaller than the first, and then we update the boundary so that we start from the second value. We consider that to be the smallest and find the smallest on third onwards, and we swap over and over again until no swaps occur, and that's what we did right here. We did a loop within a loop structure. We said while I is less than the length of names and while j is less than the length of names, we continue to do this over and over again, and it was able to sort the given names that we have. And this is the swapping technique, Python. This is only possible because lists are mutable. Since lists are mutable, we're asking, hey, names at this index of I, you're going to be taking a value and mutating yourself to the names at smallest index. And then names at smallest index is going to take the value of names I, which was held in previous execution, and it remembers because this is the swapping semantics that is used in Python to swap two values at a mutable database. And that's what we did. And then for us to write data onto a separate file, we use the W argument to say that we're writing. You want to write the new pathway of the text file or whatever you want to create in the first argument, and then you just use the write method with the data underscore file, and you were able to write and insert data like so. And as always, thank you for watching and stay classy.